Good morning, Tina. Good morning to you students. Tomorrow we will start Demoivre's theorem. Today we will start Demoivre's theorem LAQs, Nana. Good morning all of you. So today we'll start long answer type questions. VSAQs over yesterday. Now we will start LAQs, long answer type questions. This carries 7 marks. In this chapter, one question will be there in IPE. So first I am writing LAQs. LAQs question number 1, first bit. In first bit, 3 problems are there. So if n is a positive integer, n is a positive integer, prove the following. Prove the following. First bit is, first question, this important question, that is 1 plus I whole to the power of n plus 1 minus I whole to the power of n equal to 2 to the power of n by 2 plus 1 into cos n pi by 4. This is the question. LAQs, VSAQs over yesterday. Now we will start LAQs. If n is a positive integer, prove the following. In first bit, 3 problems are there. Then go to the now first question. 1 plus I whole to the power of n plus 1 minus I whole to the power of n equal to, we have to prove that 2 to the power of n by 2 plus 1 into cos n pi by 4. So let us take LHS. So for first LHS, I am doing LHS solution 1 plus I whole to the power of n plus 1 minus I whole to the power of n. Now consider 1 plus I whole to the 1 plus I, first term is 1 plus I is there. So I am taking 1 plus I upwards, power raised to n, afterwards I will see. So 1 plus I means it is in the form of complex number. Any complex number always in the form, if x plus iy is a complex number, then r into cos theta plus I sin theta, where r is the modulus, theta is the argument, then we can write any complex number is always of the form. This is known as modulus amplitude form or polar form. Already we learned that. So here 1 plus I is there. So write it as first change into polar form. Polar form nothing but modulus amplitude form. Then we can substitute in the Demoivre's only. In terms of always any complex number in the form of cos theta. That's why we are writing always modulus amplitude form. So where r equal to what you write? Root over x square plus y square. X square plus y square, this is the modulus. If theta is nothing but tan inverse of y by x, this is the basic formula. So now first substitute r. R means what here? 1 root over 1 square plus 1 square. Don't write I square, the coefficient only, that is root 2. Therefore the 1 plus I modulus is root 2. So multiply root 2 into, so that is theta means what you write here? Theta means tan inverse of y by x. Y means 1, y means 1, x means 1. That is tan inverse 1, nothing but pi by 4. Theta equal to pi by 4. So write as always root 2 into cos pi by 4 plus I sin pi by 4. This is the modulus amplitude form of a complex number. That is the formula for any complex number is x plus iy in the modulus, that is modulus amplitude form, that is r into cos theta plus I sin theta, where r equal to root over x square plus y square and theta equal to argument, that is tan inverse of y by x. If x is here positive now, so tan inverse y by x. So now substitute for 1 plus I. So root over 1 plus 1 square plus, don't write I square, coefficient of I is 1, that is root 2. So that is r is the root 2. So substitute in this modulus amplitude form, root 2 into t for theta means tan inverse of y by x, that is tan inverse of coefficient of x is 1, I is 1 and x is 1. So that is theta equal to pi by 4. That is nothing but 1 plus I in the modulus amplitude form is root 2 into cos pi by 4 plus I sin pi by 4. Next, in now power raised to the power is given 1 plus I whole to the power of n. So that is why we write here root 2 into cos pi by 4 plus I sin pi by 4 whole to the power of total value raised to the power n. So this is nothing but 2 to the power of root 2 means 1 by 2, as power n nothing but 2 to the power of n by 2. As per Demoivre's, we can apply what is the formula for Demoivre's? Cos theta plus I sin theta whole to the power of n. That is nothing but we can write as per Demoivre's, power join with argument, that is cos n theta plus I sin n theta. This is the formula for Demoivre's. So that is I sin n theta, that is cos theta plus I sin theta whole to the power of n equal to cos n theta plus I sin n theta. This is the formula for Demoivre's. Same thing as to now supplying this formula. So where cos n pi by 4 power joined with argument I sin n pi by 4. This is the value for 1 plus I whole to the power of n. Similarly, given that 1 minus I whole to the power of n. So we can write as 2 to the power of n by 2 into, just replace by plus as to minus, nothing but there is no change in the process, they only change with minus only. That's why we are writing same thing. So that is I into sine of n pi by 4. Okay, 1 plus I whole to the power of n is nothing but 2 to the power of n by 2, n pi by 4, 2 to the power of n by 2 into cos n pi by 4 plus I sin n pi by 4. Similarly, the term is given 1 minus I whole to the power of n, that is nothing but 2 to the power of n by 2 into cos n pi by 4 minus I sin n pi by 4. Just sign only plus in between. There is only some small change, that is 1 plus I to 1 minus I. It is plus is there, we can write also here minus, only difference is minus. Now LHS is given, then therefore 1 plus I whole to the power of n plus 1 minus I whole to the power of n, nothing but we can add both terms. In both terms 2 power n by 2 is common, that is cos n pi by 4 plus I sin n pi by 4 plus cos n pi by 4 plus minus I sin n pi by 4. What we have done? So 2 to the power of n by 2 in both terms is common. In the brackets I am writing in between plus cos n pi by 4 plus I sin n pi by 4 plus cos n pi by 4 minus I sin n pi by 4. So this I sin terms will be cancelled. Then you get 2 to the power of n by 2 into cos n pi by 4, cos n pi by 4, nothing but 2 cos, 2 times of cos, that is 2 cos n pi by 4. Now bases are equal, power should be added, that is 2 to the power of n by 2 plus 1 into cos n pi by 4. Hence proved. This is carries 7 marks in the IPE. This is most important question. So practice so many times. For first question we will have the question bank also. This is the first question. What is given, what would have taken here? If n is a positive integer, prove the following. That is 1 plus I whole to the power of n plus 1 minus I whole to the power of n equal to 2 to the power of n by 2 plus 1 into cos n pi by 4. So let us take the LHS. For first consider the first term 1 plus I. This is only based on the form of x plus iy equal to r into cos theta plus I sin theta. Any complex number of we can write as, where is r is the modulus, theta is the argument, we can write as modulus amplitude form, always in the cis form. That's why we are taking here r into cos theta plus I sin theta, where r equal to write as root over x square plus y square, and theta is nothing but tan inverse of y by x, where r equal to here the coefficients of x and y, that is you get root 2, and theta equal to tan inverse of y by x means theta equal to pi by 4. So write as 1 plus I in the modulus amplitude form is root 2 into cos of pi by 4 plus I sin pi by 4. And next power raised to n. So that is total thing raised to as power n. Root 2 means 2 to the power of 1 by 2 whole to the power of n, nothing but 2 to the power of n by 2 into cos of angle. So the power joined with argument, that is cos n pi by 4 plus I sin n pi by 4. Why? Because Demoivre's theorem formula, cos theta plus I sin theta whole to the power of n equal to cos n theta plus I sin n theta. That's why we are writing the power joined with argument, that is cos n pi by 4 plus I sin n pi by 4. This is the value for first term, 1 plus I whole to the power of n. Similarly, 1 minus I whole to the power of n. Both are same, just replace by plus as to minus only. So 2 to the power of n by 2 into cos n pi by 4 minus I sin n pi by 4. Then in the LHS part is given, we can add 2 to the power of n by 2 is common. This term will be adding in between. So sine terms will be cancelled. Cos n pi by 4, cos n pi by 4, that is 2 cos n pi by 4. Nothing but base are 2 to the power of 1 by 2. Here not there means 1. Base are equal, power should be added. That is why. So 2 to the power of n by 2 plus 1 into cos n pi by 4. This is nothing but RH of the given question, RHS of the given statement. So therefore this carries most important in IP also 7 marks. Please all of you make a note, Nana. So 1 plus I whole to the power of n plus 1 minus I whole to the power of 1 minus I whole to the power of n equal to 2 to the power of n by 2 plus 1 into cos n pi by 4. This formula should write all of you. This carries also marks for in IPE. So all don't write directly. All those formulas you write at another side, rough side place. Next go to the second question. Question number 2. Question number 2, that is p plus iq whole to the power of 1 by n plus p minus iq whole to the power of 1 by n equal to 2 into p square plus q square whole to the power of 1 by 2n into cos of 1 by n into tan inverse of q by p. So that is same, but complex numbers are given. In the previous question 1 plus I is given, here only p plus iq is given. P plus iq whole to the power of 1 by n plus p minus iq whole to the power of 1 by n equal to 2 into p square plus q square whole to the power of 1 by 2n into cos of multiple angle of 1 by n into tan inverse of q by p is given. Same thing, Nana. First any complex number always in the form of r into modulus amplitude form. Just now we already done. So in the same way I am doing here. LHS part I am taking. That is LHS part is p plus iq whole to the power of 1 by n plus p minus iq whole to the power of iq whole to the power of 1 by n. Consider first part of p plus iq. P plus iq nothing but always any complex number. In previous we already written r into cos theta plus I sin theta, where r is equal to nothing but root over x square, real part square plus imaginary part square. For theta equal to write as tan inverse of y by x. This is the most important for this any complex number. So this is the basic formula of modulus amplitude form. In this way we can write as p plus iq. If it is x plus iy, r into cos theta plus I sin theta, where r equal to root over x square plus y square, theta equal to tan inverse y by x. In the similar way, this has to write as to r into means r here what? x p square plus q square into cos theta. Theta means we have to find, that is cos theta. Cos theta means we have to write as, so write as cos theta. For our convenience we can treat as, first I am writing in the similar way, just I am writing like this. So that is why root over p square plus q square into multiplied by p by root over p square plus q square plus I into q by root over p square plus q square. So that is why just I am doing multiply and divide with this number, p square plus q square with this, nothing but p can you get. Similarly p square plus q square nothing but iq. In this way we can write as, it is in the form r into cos theta plus I sin theta. So where r equal to here, cos theta equal to, instead of this place is nothing but p by root over p square plus q square, and sin theta is nothing but q by root over p square plus q square. What should have done? Just multiply and divide with root over p square. R means nothing but, what the value for r means, just square root of real part square plus imaginary part square. Just doing multiply and divide. Here also multiply and divide. Now this is in the form r into cos theta plus I sin theta, where r equal to this and cos theta equal to this and sin theta equal to this. Now just for theta means, in terms of, in the question is given tan inverse, so that is why I am doing, that is sin theta by cos theta. Nothing but, what is your sin theta by nothing but q by this value, p by this value. This will be cancelled, then you get q by p. Then tan theta equal to q by p. Then theta equal to what you write here, tan inverse of q by p. In terms of answer in the form of tan inverse of q by p. That is why I am writing here cos theta and sin theta. In terms of tan means we can write as sin by cos. That is, this denominator should be cancelled, then you get q by p. Tan theta equal to q by p means you write here theta equal to tan inverse of q by p. So I am writing here in this way, root over p square plus q square into cos theta plus I into sin theta. Our convenient I am writing like this. Why? Because we are writing here this total value is cos theta, this total value is sin theta. That's why I write. So I am writing p plus iq in the form like this. Now the power raised to, that implies p plus iq whole to the power of 1 by n. Then goes to p square plus q square whole to the power of, the power goes to 1 by n. In the similar way, cos theta plus I sin theta whole to the power of 1 by n. The power goes to this part and this part. So power goes to, power, what is the power? 1 by n. So power goes to 1 by n, this part also 1 by n. So this is nothing but p square plus q square whole to the power of, square root means 1 by 2, and here 1 by n is there. Then what you write here? 1 by 2n. And so this is in the form of Demoivre's, we can write as cos theta by n plus I sin theta by n. Why? Because power joined with augment as per Demoivre's, cos theta plus I sin theta whole to the power of n is nothing but cos n theta plus I sin n theta. That's why we are writing the power goes to join with its augment. This carries only p plus iq whole to the power of 1 by n. What we have done here? What would have done here? P plus iq in the form of r equal to root over p x square plus y square means here root over p square plus q square only I am writing. Next, cos, multiply and divide with this number. This multiply and divide. This also multiply, this divide. So this carries sin theta. This total value is sin cos theta. Now the power raised to this number 1 by n. So power goes to that 1 by n nothing but as per Demoivre's, join with argument, that is theta into 1 by n means theta by n. So here also theta by n. This carries only first part of the LHS. Similarly we can write as p minus iq whole to the power of 1 by n. Just replace by plus as to minus. So that is p square plus q square whole to the power of 1 by 2n into cos theta by n. What we have to write here? Just only the sign only, Nana. So that's why we are writing here minus I into sin theta by n. This as to first one, this as to second one. Then in between as there first part, this is the second part you think. Then what we have to take here, adding the two terms, this expression and this expression. So same thing, Nana, just by multiply and divide this term. This is cos theta, this is sin theta, power raised to 1 by n. This that means power raised to 1 by n means 1 by 2 and 1 by, that is 1 by 2n cos theta by n plus I sin theta by n. This is the first part of the LHS. Similarly, second part is p minus iq whole to the power of 1 by n. That is only just replaced by plus as to minus in between the cos theta by n minus I sin theta by n. In the question is given just only the plus is there in between, adding. That's why this first expression, second expression I am adding. What we have, what will be good, what we get, and lastly we just think and write, Nana. This is the common. This has to write as it is, this has to write as it is. Then go to sin terms will be get cancelled. Cos theta by n, cos theta by n, nothing but 2 cos. Just the previous problem like that only, same pattern. So that is cos theta by n, cos theta by n, nothing but 2 cos of theta by n. So theta means substitute here, tan inverse of q by p is there. N means same thing, right? The n means in 1 by n as to same thing. That's all. So this is to p plus iq whole to the power of n plus p minus iq whole to the power of 1 minus p minus iq whole to the power of 1 by n. So write as to all of you, please make a note. First write as p plus iq in the form of modulus amplitude form. That's why we are writing cos theta plus I sin theta whole to the power of 1 by n means power raised to 1 by n. So then simplify as to this part. Similarly, plus is there, you can write as minus. So next onwards what we have to do, so that is in between plus is mean you can add these two expression, then you get the answer. That's all. But in the place of theta you should write here tan inverse of q by p here. Right, plus sin terms will be get cancelled, Nana. Cos of theta by n nothing but 2 cos theta by n, whereas to theta you can write as tan inverse q by p. That's all. Just I am doing the next base. Therefore expression should be 1 plus 2, that is root over p plus p square plus q square whole to the power of 1 by 2n into cos theta by n plus I sin theta by n plus cos theta by n minus I sin theta by n. Just adding the expression 1 plus 2, then you get p square plus q square whole to the power of 1 by 2n, that is sin terms will be cancelled, that is 2 cos theta by n, nothing but 2 times of p square plus q square whole to the power of 1 by 2n into cos of theta means tan inverse of q by p into 1 by n is there, write as here 1 by n. This is only coefficient na. So this now hence proved. This is the value for given LHS equal to RHS. This carries also 7 marks in the IP question. P plus IQ whole to the power of 1 by n plus P minus IQ whole to the power of 1 by n. That is in the form of cos theta plus I sin theta, that is whole to the power of 1 by n raised to the power. So theta by n, that is becomes to theta by n. In the same way, square root means 1 by 2n is there. This is for p plus iq whole to the power of 1 by n. Similarly, p minus iq whole to the power of 1 by n. Just replace by plus as to minus. Then in between plus is there. So we can add the terms of first and second expressions. This is the two terms as this term is common. That's why I am writing brackets as it is. So that is cos theta by n plus I sin theta by n, plus cos theta by n minus I sin theta by n. Sin terms will be cancelled, then you get cos theta by n, that is 2 cos theta by n. So that is 2 is first term as a multiple this. So 2 into root p square plus q square 1 by 2n into cos of theta by n. But theta equal to what we write in the previously we proved that theta equal to tan inverse of q by p is there. Theta equal to tan inverse of q by p in previously we've already proved that. So that's why we are writing here theta equal to tan inverse q by p as 1 by n coefficient means before you write. That's all. This is the question. Next go to the third question, that is question number 3. 1 plus cos theta plus I sin theta whole to the power of n plus 1 plus cos theta minus I sin theta whole to the power of n equal to 2 to the power of n plus 1 into cos to the power of n theta by n, cos to the power of n nana, and next term cos of n theta by 2. This is in the terms of angle n theta by 2. This is only the power raised to n. This is a multiple of n. This is a power raised to n. That is the difference. What is the question is given? 1 plus cos theta plus I sin theta whole to the power of n plus 1 plus cos theta minus I sin theta whole to the power of n equal to 2 to the power of n plus 1 into cos to the power of n of angle theta by n into cos of n theta by 2. This has to prove that for for I am taking for our problem I am taking these values by go to the first year trigonometry nana. This formulas already learned. 1 plus cos theta and sin theta formulas are there. What is the formula for 1 plus cos theta? 2 cos square theta by 2. Sin theta is nothing but 2 sin theta by 2 cos theta by 2. This in the terms of half angles are there. That's why we are writing half angle formula. So that is 1 plus cos theta is nothing but 1 plus cos theta 2 cos square theta by 2, and sin theta is nothing but 2 sin theta by 2 into cos theta by 2. Whereas 1 plus cos 2 theta is 2 cos square theta. Next 1 plus cos theta is nothing but half angle means 2 cos square theta by 2. Sin 2 theta formula nana, 2 sin theta cos theta, but I am writing here sin theta only. That's why we are writing half angles 2 sin theta by 2 cos theta by 2. So that is why we are doing in the first year formula. That's why we are taken as first LHS part. LHS part is getting nothing but solution 1 plus cos theta plus I sin theta plus I sin theta whole to the power of n plus 1 plus cos theta minus I sin theta whole to the power of n. Just replace by whatever formulas are there, you can substitute and take the common and add both terms. 1 plus 2 in previous method, sin terms will be cancelled, both will be in the terms of cos term only. That is the RHS. This is the process, same thing process nana. Just what the questions are, all of you please make a note. So first only the formula replaced by 1 plus cos theta, that is 2 cos square theta by 2, and sin theta is nothing but 2 sin theta by 2 into cos theta by 2. In the same way second part also same. So that is why first we have to substitute in this one. So that is in the next page, that is LHS. Now consider 1 plus cos theta plus I sin theta whole to the power of n. So this is the formula for 1 plus cos theta, and we have formula this. That's why we are writing 2 cos square theta by 2 plus I into 2 sin theta by 2 cos theta by 2 whole to the power of n. Just doing the 1 plus cos theta is this formula, sin theta as to this formula. Now I am taking the common. 2 cos theta by 2 is common in the both terms. So that is why I am doing the common as part of 2 also common. So that is why cos theta by 2 plus I sin theta by 2 whole to the power of n. So this nothing but the power goes to this number, this term, that is power raised to the power 2 power n cos power n of theta by 2. 2 power n cos power n of theta by 2. Now it is in the form of Demoivre's. That's why the power goes to the join with its argument cos n theta by 2 plus I sin n theta by 2. This is the number na, that's why we are writing 2 power n into cos power of n of theta by 2. But this has to Demoivre's. This form is there, has the power of n. Since why? Because we are writing cos theta plus I sin theta whole to the power of n is nothing but cos n theta plus I sin n theta. If whenever the cos theta plus I sin theta whole to the power of n is there, we can join with the argument, that is cos n theta plus I sin n theta. This is n theta. So that's why in the similar way cos n theta by 2 plus I sin n theta by 2, but this power goes to the raised to the power 2 power n into cos power. If it is suppose 2 is there, what should we do? Cos square only, ra? In the similar way cos power n of theta by 2. This is in the form of Demoivre's. That is the part of first LHS first part. This is carries 1 plus cos theta plus I sin theta whole to the power. In similarly 1 plus cos theta minus I sin theta whole to the power of n. That is also you can get 2 power n of cos power of n by 2. What should we write here, Nana? Cos n theta by 2, just only the sign difference minus I sin n theta by 2. That's all. Don't write all those, just write as to formula. And similarly we can write 1 plus cos theta minus I sin theta whole to the power of n. Just replace by plus as to minus. This is the first part, this is the second part. Now by adding 1 plus 2. In both terms 2 power n into cos power of n of theta by 2 as common. Then write as cos n theta by 2 plus I sin n theta by 2 plus cos n theta by 2 minus I sin n theta by 2. Now sin terms will be cancelled. Then goes to 2 power n into cos power of n of theta by 2. And cos terms 2 times are there. That is 2 times of cos n theta by 2. Now bases are equal, power should be added here 2. Here 2 power n means 2 power 1 means you can write as 2 power n plus 1 into cos power n of theta by 2 into cos of n theta by 2. Then proved. All three problems are in the same pattern, Nana. Don't think another way. Just write as to same form. This form you have to convert it always. Why? Because it is in the form of Demoivre's. Demoivre's means this formula. So all the problems convert into like this method. Just take the formula 2 cos square theta by 2. Sin theta is I into 2 sin theta by 2 cos theta by 2, Nana. From this 2 cos theta by 2 is common. Cos theta by 2 plus I sin theta by 2. So the power raised to the power here, the power also here come. So that is m cos n theta by 2 as per Demoivre's. This is the first expression. In similar way it is plus is there, here in the question it is minus. So just replace by plus as to second part. This add 1 plus 2. In both terms this term is common. That's why writing in the bracket terms, and sin terms will be get cancelled. Cos n theta by 2, cos n theta by 2, 2 times of cos n theta by 2. Here 2 power n and 2 is nothing but base are equal, power should be added. That's why we are writing here 2 power n plus 1 into cos to the power of n of theta by 2 cos of n theta by 2. That's all. This carries 7 marks. So all of you please make a note. Then go to the second LAQ, very most important question, that is question number 2. And question number 3, most important question. This carries all 7 marks in the IP. Just practice so much. So many times you have to write, and formulas you have to learn. Demoivre's formulas, all those, and 1 plus cos theta and sin theta, all those. Wherever modulus amplitude form, all those you have to write. So write and learn, that is very important. This carries 7 marks questions in the IP question. This alone, this chapter weightage also 1 LAQ and 1 VSAQ. So that is only in this one exercise only. That's why we are getting very easily. Just practice once again. so many times, not once again, so many times you have to practice. So then go to the LAQ second question, Nana. That is given that if alpha and beta are the roots of x square minus 2x plus 4 equal to 0, then show that alpha power n plus beta power n equal to same method, Nana, 2 power of n plus 1 into cos n pi by 3. That the question is given. So I'm going second LAQ. Second LAQ, that is LAQ number 2, most important question. So if alpha and beta are the roots of x square minus 2x plus 4 equal to 0, then show that alpha power n plus beta power n equal to 2 to the power of n plus 1 into cos n pi by 3. All those are similar method. Just given that alpha and beta, for why? Because it is a quadratic equation. Quadratic equation means you have to get the values roots as to two roots. Let it be named as alpha and beta. Then show that the power, the root of the power raised to n, beta as second root, power to n, then carries 2 power n plus 1 into cos n pi by 3. So let consider. So given the equation is, therefore given quadratic equation is x square minus 2x plus 4 equal to 0. How will you get the roots? The question is given both terms, both roots will be given. So that is, let it be alpha and beta. For those we have to find roots. So that is for finding the roots, x equal to minus b plus or minus root over b square minus 4ac by 2a, general basic formula. So here a equal to 1, b equal to minus 2 and c equal to 4. Then substitute. So that is x equal to, I am writing here, 2 plus or minus root over 2 square means 4, 4 into 4, 1 into 4 means 4 by 2a, 2a means 2. That is why we are having the roots 1 plus 1, 4 minus 16. 4 minus 16 nothing but minus 12 by 2. So that is why you can get 2 plus or minus, square root of minus 12 means 12. 4 3 are 12. 4 3 are 12 means 2 root 3. So 2 root 3 into minus is there means you can write as I. So 2 cancel, then you get, that is 1 plus or minus root 3i. Don't get confused, it is square root of minus 12. 4 into 3, 4 means 2 outside, I is there, I square is minus 1, that's why you are writing I outside. So 2 root 3, 2 as common, then you get 1 plus or minus root 3i. Therefore alpha and beta are the roots of the equation. Just write here this, alpha and beta are the roots of given equation, are the roots that implies alpha equal to 1 plus root 3i and same time beta equal to 1 minus root 3i. So that is where next we have to find in the LHS part is given alpha power n plus beta power n is given. That is why we are taking alpha power n first. That is 1 plus root 3i whole to the power of n, and plus beta power n also given. That is why plus 1 minus root 3i whole to the power of n. We have to find this value. So for this value, so we have to do as, what should we have to do? That is that nothing but alpha first change into alpha power n. That is alpha is given, just I am writing alpha 1 plus root 3i whole to the, now it is changed into modulus amplitude form. First alpha I am taking. So what is the value for r into cos theta plus I sin theta form? R equal to what we have to do? R equal to root over x square plus y square, that is you get 2. Theta equal to tan inverse of y by x, tan inverse of root 3, nothing but pi by 3. So theta equal to pi by 3 and r equal to 2. Now so write as in the form of x plus iy is nothing but r into cos theta plus I sin theta form, Nana. This is modulus amplitude form. This rough part you have to do separated part. Now sum convert into r equal to 2 into cos of pi by 3 plus I sin pi by 3. First convert into cis form, that is modulus amplitude form. So that's why we are taking r equal to 2, theta equal to tan inverse of what formula is? Theta equal to tan inverse of y by x. That's why we are writing root 3 by 1, that is tan inverse root 3 means pi by 3. Now substitute in the modulus amplitude form. R is there 2 into cos pi by 3 plus I sin pi by 3. Now change into alpha power n, that is 2 power n into cos, I am writing directly cos n pi by 3 plus I sin n pi by 3. Why? Because 2 power total part carries whole to the power of n, that is 2 power n cos n pi by 3 plus I sin n pi by 3, that is Demoivre's formula. This is similarly we can add by beta power n. Beta power n right has to 2 power n into in bracket terms, Nana, 2 power n into cos n pi by 3 minus I sin n pi by 3. Just replace by plus has to minus y, because this is 1 plus root 3, this is 1 minus root 3. So power raised to alpha, all 2 power n, that means 2 power n in power join with augment cos n pi by 3 plus I sin n pi by 3. So beta power n is nothing but 2 power n into cos n pi by 3 minus I sin n pi by 3. Then adding the two, both, why? Because alpha power n plus beta power n. By adding we can get sin term will be cancelled, then you get 2 power n is common, cos n pi by 3, cos n pi by 3, 2 times of cos n pi by 3, 2 power n into 2 nothing but 2 power n plus 1 into cos n pi by 3. That's all. This total 4 problems are in the same method, Nana. Next doing this is as to first part, this as to second part. Just what should have done here? The given quadratic equation is x squared minus 2x plus 4. So that is x squared minus 2x plus 4 means the finding the roots nothing but minus b plus or minus root over b square minus 4ac by 2a. That's why we are doing x equal to 2 plus or minus root over 4 minus 4 into the calculation part. So that is 1 plus or minus root 3i. Let us the value roots are taken as alpha equal to 1 plus root 3i and beta equal to 1 minus root 3i. So alpha equal to change into modulus amplitude form, 2 into some part this value formula and all raised to the power, and beta also this raised to the power. Then by adding, so then you get alpha power n plus beta power n is nothing but 2 to the power of n as common, cos n pi by 3 plus I sin n pi by 3 and plus cos n pi by 3 minus I sin n pi by 3 minus I sin n pi by 3. Then sin terms will be cancelled, 2 to the power of n into 2 cos n pi by 3. Then base are equal, power should be added, that is get 2 power n plus 1 into cos of n pi by 3. So that's all. This carries also very important question. This carries 7 marks. So all of you make a note and practice more, Nana. Thank you for watching.